On page 74, forgot to show you that the magnet, the line goes from north to south. I will put this link below. Yeah, that's the magnet. Lesson 28, unit 28. Should be chapter 28, it's okay. Or lesson 28. Unit is a bigger content. We should say lesson 28. If you have a chance to go to the parks, you will be able to sit on carriages of a small train running on high railways at the level of a roof, to take a stroll around the parks, watch the city. You know, that train runs smoothly, doesn't release smoke, doesn't consume fuel, but runs by the electric current. How does the electric current rotate the motor and operate a train weigh 10 of tons? The structure, principle, and operation of a DC motor. Main parts of a DC motor. A DC motor consists of two main parts, a magnet and a wire frame. Besides, for the wire frame to be able to rotate continuously, there must be a collector where brushes C1, C2 transmit the electric current from the power supply to the wire frame. Find out the diagram as shown in figure 28.1 and the model of a DC motor to indicate its main parts. Operation of a DC motor. A DC motor works based on the effect of the magnetic field on the current carrying wire frame in the electric field. Express the electromagnetic force acting on the conductors AB and CD of the wire frame when there is an electric current through it, as shown in figure 28.1. Guess what happens with the wire frame at that time? Perform an experiment to check your guess by turning on the switch so that the electric current enters the wire frame of the model. Page 76. Conclusion. A DC motor consists of two main parts, a magnet to create magnetic field, stationary part, and a coil to let the current flow through. rotating part. The stationary part is called stator, and the rotating part is called rotor. Stator and rotor, stator, rotor. When the coil ABCD is placed in the magnetic field and the electric current flows through it, the coil will rotate under the effect of electromagnetic force. DC motors in engineering. The structure of a DC motor in engineering. Observe the figure 28.2 to indicate the main parts of the DC motor in engineering. Comment on the differences of its two parts in comparison with the model of the motor you have just found out. Conclusion. In a technical electric motor, the part creating magnetic field is electromagnetic. The rotating part of a technical electric motor is not only a coil, but it also consists of many coils inclined and parallel to the axle of a cylindrical block, which is made from combined technical steel leaves. In addition to DC motors, there are alternating current motors. Page 78. Energy transformation in electric motors. When operating, from which form into which form does an electric motor transform energy? From electrical energy to mechanical energy. Application. What direction does the coil, as shown in figure 28.3, rotate in? I think clockwise. Why do people not use a permanent magnet to create magnetic field when making an electric motor with high power? I'm not sure. Maybe you tell me. Give some applications of electric motors that you know. DC motors work based on the effect of magnetic field on the current carrying coil in that magnetic field. A DC motor consists of two main parts: a magnet to create magnetic field and a coil through which the current passes. When a DC motor works, the electric energy is transformed into mechanical energy. You may not know, based on the phenomenon of electromagnetic force acting on the current carrying coil, people can make galvanometers, which are main parts of electric measuring devices, such as ammeters, voltmeters. Figure 28.4 describes the operating principle of a rotating frame galvanometer. When there is a current passing through the coil K placed in the magnetic field of the magnet C, under the effect of the electromagnetic force, the wire frame rotates around the axle OO' and makes the needle Q rotate accordingly.